Hello good dear viewers. In this tutorial we are going to learn how to apply the Moivre theorem in expanding powers of a complex number, and we are going to use only one example in this tutorial to show how it works. Alright, the Moivre theorem stated that if for a given complex number z, which is written in a polar form, r multiplied by cosine of theta plus I sine of theta, it stated that z to the power of n, for which n is an integer, this is the same thing as r raised to the power of this n, then multiply by cosine of this n multiplied by the angle, then plus I sine of that same n multiplied by the angle. So this is exactly what the Moivre theorem stated. So let's give an example to see how it works. For example, let a complex number z be equal to 1 plus I, very simple complex number. So what if we want to raise z to the power of 5? You know it is the same thing as 1 plus I to the power of 5, which means 1 plus I times 1 plus I times 1 plus I up to 5 places, which is a very big work, right? So instead we can apply this formula in evaluating this. All we need is r and theta. So let's find r. So from here, if we are looking for the r, which is the modulus, it is equal to the square root of a plus b. A is the real part and b is the imaginary part. A is 1 squared plus b, which is just the coefficient of I, is also 1 squared. 1 squared and 1 squared are all 1. 1 plus 1 is equal to 2. Therefore, r is equal to square root of 2. Then for the angle theta, you know it is the same thing as tan inverse of what? B divided by a. B is 1, a is 1. 1 divided by 1 is equal to 1, and tan inverse of 1 is 45 degrees, or pi by 4. So let's use the radian. Theta equal to pi by 4. Therefore, the complex number in the polar form is now equal to r, which we have as square root of 2, multiplied by cosine of this angle pi by 4, then plus I multiplied by sine of that angle pi by 4. But remember, we want to expand z to the power of 5. So z to the power of 5, according to the Moivre theorem, it stated that it is the same thing as r to that power, then multiply by cosine of what? That n multiplied by the angle, that is 5 pi by 4, then plus I sine of that same 5 pi by 4. So now let us simplify this. What is root 2 to the power of 5? Let me do it here. Root 2 to the power of 5 is equal to root of 2 to the power of 5, and this is equal to root of what? 2 to the power of 1 multiplied by 2 to the power of 4 according to law of indices, and 2 to the power of 4 is 16. Square root of 16 is 4, so this is the same thing as 4 root of what? 2. Therefore we have 4 root of 2 multiplied by cosine of 5 pi by 4 is equal to negative root 2 divided by 2. Negative root 2 divided by 2. Then plus I multiplied by sine of 5 pi by 4 is the same thing, negative root 2 divided by 2. So what we're going to do next is to expand. Because of this negative multiplied by a positive number, we have negative 4 root 2 multiplied by root 2 divided by 2. Then plus, this is also negative. We have negative of what? 4 root 2 multiplied by root 2 divided by 2. Root 2 times root 2 is what? 2. 2 times 4 is 8. 8 divided by 2 is 4. But because of this negative, we have negative 4. This is negative 4. This and this will become negative. This is negative. and this is also 4. But remember, we have our I here. So we have 4I, which implies that 1 plus I raised to the power of 5 is the same thing as negative 4 minus 4I according to the Moivre's theorem. But now I want us to use our normal expansion to expand this to see whether we're going to get negative 4I. So 1 plus I raised to the power of 5, which is the same thing as 1 plus I multiplied by 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 1 plus I. So let me take 2 at a time. I want to start by expanding 1 plus I multiplied by 1 plus I. You know it is going to be first term squared plus second term squared plus 2 multiplied by first term multiplied by second term. 1 times I is just I, right? This is equal to 1 squared is 1, but I squared is negative 1 according to definition, then plus 2I. 1 minus 1 is 0, so we have only 2I. So we have seen that the first 2 is equal to 2I. The second 2 will also be equal to 2I. So what if we should multiply first 4 together, leaving 1 extra left? 1 plus I multiplied by 1 plus I multiplied by 1 plus I multiplied by 1 plus I. We have seen that the first 2 will give us 2I, and the second 2 will also be equal to 2I. We have 2I times 2I, which is going to give us 4I squared, right? But remember that I squared is equal to what? Negative 1. Therefore, the whole of this will be negative 4. Now, the expansion of all of this 4 is equal to negative 4. But remember, we have 1 left, which is what? 1 plus I. So since the first 4 is just negative 4, all we have to do is to take this negative 4 and multiply it by 1 plus I. By doing so, negative 4 times 1 is negative 4, and negative 4 times I is negative 4I, which implies that z to the power of 5 is equal to negative 4I, which is exactly the same thing as using the Moivre's theorem to expand that z to the power of 5. So since we have seen that it is applicable, subsequently we're not going to be using this normal expansion. We'll be applying the Moivre's theorem to expand our complex numbers. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.